Algebra 2, Lesson 85, Systems of Nonlinear Equations. So, all we're talking about here is when we have two equations that look kind of like this, and we have to solve for x and y. Normally, these two equations do not have exponents, right? Now they're going to start having exponents in them. What that means for us is that the equation that has an exponent in it is not a straight line. The bottom equation, we know this is going to be the equation of a straight line. The top equation, this is actually the equation of a circle with a radius of 3 at the origin of 0, 0. You don't need to know all that yet, but all you need to know is that this is a curvy line. So anytime you see an exponent of 2 in an equation, that's going to graph something curvy. So the two equations we were just looking at actually make this graph. One of them makes the straight line, now the other one makes the circle. And if you remember correctly, when we're solving two systems of equations, we're looking for the point where the two lines meet. However, one of these lines is curvy, which means that these lines are going to meet at not one, but 2 points. So, and then we see all different instances of this here. So the types of curvy lines that will be represented, the x squared y squared term is a circle. Here we have an ellipse, which is going to look like this. We have parabolas, which look like this. And notice in the parabola the x is squared, but the y is not. And then we also have hyperbolas, which also have an x and y term both squared. So these are the different types of curvy lines that we're going to be dealing with, and you'll notice that in all of these, if we were to run a straight line across the graph, somewhere we're going to hit these at 2 points, a minimum of 2 points. I think, let me see here, if we hit this one, nope, that's going to be 2 points, 2 points, 2 points. Okay, yeah, it looks like we'll only be getting 2 points, no matter which way that we turn the graph, which I think it's possible to get 4 points. I'm just trying to make sure, because I know we get 1, 2. What if we ran it 1, 2? I guess it would always be 2. I remember thinking that it was possible to get 4 points, but sometimes we're going to have 2 answers for one of these systems of linear equation problems. So, yeah, we'll go ahead and we'll solve this practice problem. And that'll show us why. So we have to solve x squared plus y squared equals 9 over 2x minus y equals 3. So to solve this, we're definitely going to have to use substitution. Elimination is not possible, because if we tried to square this bottom half, we would have to do foiling, and then that would change everything. It would not work out, so we absolutely have to use substitution. So let's rewrite this bottom equation. If I were to add y to each side, I would get 2x minus 3 equals y. So I'm rewriting this equation by adding y to each side and then subtracting 3 from each side. That moves that one over here, and now it's solved for y. Once it's solved for y, so that's your first step. Solve your linear equation for x or y. I solve for y. So now that I know that y equals this, I'm going to substitute that in here. So I have x squared plus parentheses 2x minus 3 squared, which is the y squared, and that's going to equal 9. Here I'm going to FOIL, and it's okay that I'm foiling here because I've only got one unknown. So if I were to do 2x minus 3 times 2x minus 3, what I get is 4x squared. I'm going to have a plus 9, and then I'm going to have minus 6 minus 12x. All right, so I did that pretty quick. The middle terms would have been negative 6x, negative 6x. So the final quadrilateral, or quadratic, would have been this. I have an x squared in front, and then I have 9 at the end. Now, solve this. I'm going to add like terms. So now I've got 5x squared. Minus 12x, I can subtract 9 from each side, and that's going to give me 0. Okay. So what I see here is I'm going to get 5x squared minus 12x equals 0. Can I solve this through factoring? yeah, I can pull out a greatest common factor of x. So through zero factor theorem, I'm going to try to solve this. The greatest common factor here is x. I'll pull that out as the greatest common factor. And then I rewrite this as 5x minus 12 equals 0. So for this one, I have two possibilities, okay? So one possibility is that x is equal to 0, right? That's going to be my first ordered pair. X is 0, right? The second ordered pair is going to be if x is this value, right? So what value would make this 0? So I have to kind of solve this parenthesis. I have to figure out what value of x would make this parenthesis equal to 0. Well, 5 times 2 is 10, so it's actually going to have to be a little bit bigger than 2. To figure this out, I actually have to divide 12 by 5, or 12 over 5, right? So the other answer is 12 over 5, because if I were to multiply 5 over 1 times 12 over 5, that would cancel, giving me the number 12. 12 minus 12 would be 0. That's what I'm going for, right? So I solve for this x, I solve for this one, and I get 12 over 5. Right, now that I've got these two x values, I have to figure out my y values. So I'm going to take these, and then I'm going to plug both of them into this equation, right? So the first one being 0, if I plug 0 into this equation, 0 times 2 minus 3 is just going to be negative 3, right? So that works. So the first pair is going to be 0, comma, negative 3. That's one of my answers. Now the other answer, I have to plug in 12 over 5. So 2 times 12 over 5 minus 3 is going to equal y. 2 times 12 over 5 is 24 over 5. 24 over 5 minus 3. So I can either turn this into a fraction or this into a mixed number. I'll turn this into a mixed number. So what I end up getting is 4 and 4/5. 4 and 4/5 minus 3 is going to give me 1 and 4/5. And then I can turn this back into a fraction or an improper fraction. That's going to give me 24 over 5. So 12 over 5 and 24 over 5. And that is my other answer. Yeah, I mean, the only thing new here is, we have to do a little bit of quadratic simplification on our equation. And then when you get to the end and you have to use zero factor theorem, you're going to have two values for x. Once you get both of those values, substitute to find both your values for y. And you're going to have to use substitution on these. If you try to use elimination, it's not going to work. So anytime you see a system of linear equations like this, where you've got an x squared or a y squared in it, no substitution, only use elimination. That's it for today's lesson. If you have any questions, let me know on Moodle.